All right, so let's take a look at this next example here. Here in this problem, the goal, again, when we read the question sentence, here it says, express this travel time in hours and minutes. And if we read the first sentence, given how short the problem really is, we see that it says, Sarah's train journey from Boston to New York City, takes 255 minutes. So if we understand this properly, we are starting with 255 minutes. And we need to turn this into hours and minutes. So when we take a look here, everyone, well, we are taking this as a small unit going to a bigger unit because minutes are smaller than hours. I think we can all agree there. And everybody, what did we say we should do when we are going from a small to a big unit? Correct, division. That is division. We will divide. Now, although we haven't gone through it yet in today's class, I think we should all know this. What number are we supposed to be dividing by? How many minutes are contained in 1 hour? Correct. 60 minutes encompass 1 hour. 1 hour equals 60 minutes. So that is the value that we will be dividing by. Now let's get to work here. I'm going to divide 60 into 255. Again, 255 divided by 60. And so now that we're here, everybody, how many times does 60 go into 255? That'll be 4 times. So what does the 4 represent, everybody? We have made 4 groups of 60. The 4 represents what? Hours. Yeah, 4 whole hours. Boom. Now we need to understand what the number of remaining minutes are. 60 times 4, that's going to be 240. And when we subtract 255 minus 240, that's a remainder of 15. 15 remaining what? What units should we use there? Correct, minutes. 15 remaining minutes. And there we go. A very straightforward one. I had to kind of, toss you a much more doable one after that very, very lengthy one. But nonetheless, the correct answer here will be 4 hours and 15 minutes. That would be choice B in this case. Now, everybody, just want to remind you, the only difference between the previous question and this one, in a lot of ways, is just the numbers. It's really just the numbers. So keep up the great work here. Let's go ahead and turn our attention over to the next problem. Let me go ahead and pause this here and let's keep it up. All right, so in this next question, we are going to begin, as always, reading that question sentence first. And it says, what is the ratio of motorcycles to cars? So that's the comparison we're trying to make. So let me write that down over here. I'm going to write, again, motorcycles on the left. And then we have cars on the right. So that is what I want. Again, the ratio of motorcycles to cars. So if I can get one number here and another number there, and have a direct connection, then I have myself a ratio. Yeah, we'll have to simplify if we need to simplify, but that's what we need. The comparison, one more time, from motorcycles to cars, right there. So how are we going to do that? With a little bit of patience. I'm going to leave this up here. I'm going to begin reading this first sentence. In a parking lot, the ratio of cars to trucks is 7 to 5. Let me write that down here. I'm going to say again, let's use blue. Cars to trucks is 7 to 5. So cars, trucks, that is 7 to 5. Then up next, I'll go ahead and do this next one here in purple. And it says the ratio of motorcycles to trucks is 8 to 5. Write it in the same order, everybody. Be careful. We have motorcycles to trucks. That is going to be 8 to 5. All right, everybody. So pop quiz. What is it that we are trying to compare at the end of the day? To conclude and finalize this problem, we want to compare First blank, second blank. What are the two ideas we're comparing? Correct. Motorcycles and cars. Notice that I'm sticking to this right here. I'm sticking to what the question sentence said. That's how you have to answer the question. How does that help me? Watch this. Which of these ratios includes motorcycles, everybody? Which of these ratios, the first one or the second one, which one includes motorcycles? Yeah, the second one. So let me go ahead and move this away for a moment. And then I'll go ahead and move this one over here so I can see that I'm trying to line up at least my motorcycles. Okay. Now in the next one, okay, it's clear here to see that we have cars right there. But if we try to go ahead and bring this over here, nothing's lined up. Nothing's lined up. So what I'm going to do, watch this. Very straightforward, very simple. Anybody can do this. I'm going to move trucks to the left. This is perfectly okay. This is perfectly okay because now this gives me the opportunity to compare. Notice that I have the cars where it is, and notice that I have trucks overlapping now. Everybody in this overlap, when we overlap right here, let me use green. When we overlap trucks, do we have the same middleman, the same number for trucks? Yes, absolutely do. So because of that, that gives me the ability to go ahead and just merge these together. And when I merge these together, I can get my final comparison. Remember, I want to go from motorcycles to cars. That is the comparison 8 to 7. Boom. There's the ratio 8 to 7. And my final answer is answer choice A. Notice that it's a little bit of a puzzle, but once you get that puzzle sorted out and you're paying attention to the question sentence, notice how much easier it becomes. And here we go to this next question. So this next question reads, solve for x, and we're dealing with an absolute value equation. So to deal with this problem, it's very easy to get stressed with a problem like this, but it doesn't have to be that way if we understand really the fundamental details, the nuance. And so here's the nuance. The nuance, the knowledge that you need to know to solve this, is that the absolute value function turns essentially whatever you have as the input, it'll make it positive. That's pretty much how absolute value works in a nutshell. So when we take care of business here, here's the question you want to ask yourself. If the absolute value turns whatever is inside of it positive, is it possible for the absolute value to result in a negative? Is that possible? And the answer is no, because absolute value only measures distance. Distance is not negative, so we cannot achieve a negative with absolute value. We cannot. Quick question, answer is A. No solution.